Sometimes even the most routine and mundane repairs can spiral out of control, developing into a bit of a moral quandary for the owner. And I would say unscrupulous companies can easily put us into that situation. It's just not fair. So what do? Do you repair the amp and dump it, transferring the burden to an unsuspecting and innocent second party? Or do you become part of the machine and launder the issue through an organization who can technically repair it internally and still manage to flip it for a bit of a profit? It's a tough spot to be in. James, top of the morning to you. And thanks for your patience, and then the rest of you goons out there as well, as my voice has been recovering. Still not quite there. So what are you looking at? You're looking at the new quad of EL34s in your amp. We're coming up to 1 hour of idle time. I have biased them at 35 milliamps of plate current each at 418 plate volts. You can see a little 1 volt wiggle there. Not worried about it. So I will be running 500 millivolt or half of a volt signal through the input, and then through a dummy load at stage volume. And we're going to see if we get any sort of erratic behavior with the idle or the bias conditions here. Because as I had mentioned prior, James, your circuit board revision number falls within the range of those that are affected by that awful bias drift condition as things heat up. Though I haven't been able to recreate it here. Once the thing is sitting in its cab and subject to limited ventilation, I've no doubt that that's becoming a bit of an issue. So I have her biased right down the middle at 60%. So she's not going to be as hot as she could be, which would be another 10% up to 70, which would be the maximum. So we're going to keep her on the cooler side of that, and maybe I'll just goose her down to like 50%, which would be fine. But she's holding steady. Little mechanical noise you might hear from the power transformer in the background. But listen to this. You were running your original tubes. And have a listen. It's a lot of mechanical noise from those old Svetlanas. And then what I wanted to highlight again is just the condition of these guys. These guys were burnt. You can see the lighter colored base material gradually become blackened. And then look at the condition of the sticker. That sticker should be yellow, as this guy. And then you can see this guy was getting burnt too. And then the other two guys, let me put the stickers forward. And the same condition. They were just toasted, buddy. And just very noisy. Otherwise, you have 3/4 of the original complement of preamp tubes. Your V1 position tube is an Electro Harmonics 12AX7. Then the rest of the Marshall branded tubes that shipped with the amp from the factory. And as far as these are concerned specifically, I'd say you got some pretty long life out of the stock tubes. This is the second time, I believe, that I saw this amp. Is it the second or third time? I've lost count, and I'd have to reference my notes. So just to let you know that I'm just not comfortable applying a Band-Aid to this series of amplifier for that aforementioned reason. where I want to make sure that if you're paying for tubes and you're paying for service, that you're not going to get another issue spurred on by a factory defect. It's like a waste of your money and time, and it's just going to make you unsatisfied and frustrated. So I'll repeat the caveat / warning again that if it were me, let me make sure this amp is stable. And then once we do that, let's see where she lies. Now I'm looking at 1 milliamp increase in plate current on this pair here. I'll see if that's a trend that continues to develop. And this one is wiggling up a bit too. You'll see an inverse relationship between a plate voltage and a current there. As the plate current rises, it's going to pull that voltage down. So we want to make sure that that wiggle is just a power supply thing, and it's not an indicator that the bias itself is trying to get away from us. We were at 35 milliamps of current. Now we're sitting at 36. So let's see what happens. These are technically not burned in, though they're matched from the retailer or e-tailer. So this is part of what I do for you guys when I install new tubes. This would be off the bench and in the background as I'm working on another project. However, it's front and center here because you continue having issues. And then you can see here that we're climbing up to 37. So maybe these are burning in, and then maybe they're not. So now we're looking at a 2 milliamp increase in plate current. You have a conductive circuit board. So let's just take a look here. I'm going to continue to monitor this, and I may see if I'm able to stimulate a greater drift vector via some input signal and some rougher swing on these output tubes. So let's see what I can do. Bye. When you see this clip come back in, it'll be after about an hour. And we're back. So here's my finding. Watch, it's going to change as I'm speaking. So biased around 60 to 62% of max plate dissipation. I was getting some upward, and now look, it's doing it again, isn't it? So all this to say is we went from 35 to 39 milliamps within the span of about 45 minutes. And now, having cooled her down to about 50% max plate dissipation, I'm starting to see her wiggle her way back up again. Now, granted, this thing relies on a pretty convoluted balance circuit to get both pairs of output tubes into the appropriate range. So if during the adjustments, and I'll show it to you, and I need to adjust the angle here, so pardon me. But there it is down there. You see that? I can't get the best angle for you guys. Those two white, there's two white little PC mounted potentiometers that are flanking that male Molex end that are responsible for balancing the current between the two pairs of output tubes. That's what it's doing. So if you have it adjusted just so, you'll be on the brink of going up or down by a milliamp on one side or the other. And I'm wondering if that's what's happening to that left side meter there, which is representing the left pair of output tubes. And bear in mind, this chassis is inverted. So as the board heats up, it's going to do so exponentially quicker once this thing is rehoused in its in the combo shell, because it will be, for all intents and purposes, right side up. Instead of the heat just dissipating into the atmosphere, what's going to happen is the heat will propagate upwards into the chassis itself, and right below this little aluminum pan here that these tube clamps are mounted on is the PC board that these sockets are installed in. That will heat up directly and quickly, and it's going to cause the same issue again. It's just a matter of time before the fuses start blowing again. So this creates a moral dilemma. Like, do you spend the $800 that it's going to cost, really, to do the service, which means to replace the board, or do you launder the issue through a big retail store who can take the hit? That's the moral dilemma. That's not for me to decide, but I would recommend just getting rid of this amp, because if you're already looking at, the budget for repairs on this thing, I would just pass it along. But you're going to take a loss if you go direct, because you have to disclose it. At least the corporation can, at an internal cost, which is to say a severely discounted cost, can pay to have it done properly and then still flip it for a little bit of a profit. So you can see she's creeping up again.